Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our deep programming language series. In today's lesson, we're going to be looking at something that's a little bit more of an advanced feature, something that's probably useful if you're writing a library. But with that said, let's go ahead and take a look at this feature here. Now, the feature we're going to be looking at is actually a continuation on the previous lesson, so make sure you check that in the playlist where we talked about scope. So I'm going to go ahead and continue with this idea of scope and talk about return scope. So let's go to the documentation, let's go to the language reference, and then we're going to go ahead and find functions here, which is down here. Give that a click here. And we're going to be looking at return scope here. Okay. Now, previously, again, if you didn't watch the previous video, this idea of scope parameters is that for safe code, so whether it's safe with a colon that makes all of this safe here, or usually you'll see it right in front of the function explicitly, basically what happens is there's a escape analysis that says, well, if I have this variable here, then I want to make sure that for reference types or pointers, like is highlighted right here, I can't have some global variable that's, outside of the scope here point to something that could be temporary. In this case, a parameter that is passed by value here. Okay, so it's making a copy here. We're storing that local here, and effectively this can lead to memory unsafety. So return scope adds a little bit more to this idea. And again, this is going to be part of DIP 1000, and I'll give you my thoughts on DIP 1000 or some of the thoughts towards the end of this lesson here. But the idea is that you can actually have something escape, but only through the function's return value. Okay, so there's just going to be a little simple change here that says, yeah, I'm allowed, maybe I do something interesting with this pointer here. Okay, if I know what I'm doing here, I can, of course, let it escape through the return value. And I'll try to give a use case for, why we might want to do that, and just go ahead and illustrate this. And then a few other things from the documentation here. So again, class references, so reference types, we worked with these last time. Again, they're subject to the scope idea here, okay? Okay, and we can also, since for some class here, C, we could return the actual object. We haven't talked about this in this particular series here, but if you've come from Java or C++, right, this holds the current instance to the object of this class. So with return scope, you can escape. Okay, so let's go ahead and take a look at this. And here's what I've got here. So previously, this is where we left off in the previous video. So I'll go ahead and do a little brief recap here. Actually, let's keep all the code so you can see it on the screen here. Whoops. And I know it'll be a little bit smaller for you. But the basic idea here on this recap was I had some global variables here, a reference type and an integer type. And basically, I don't want to be able to escape or assign something to these global variables. Now, these could be globals, they could be static just to the module, they could be static as part of a class or a struct or something. Basically, any way to allow some variable that's supposed to be a temporary increase its scope or its lifetime, right? That's what this is trying to block here. Now, again, this is a preview feature of DIP 1000. So depending on when you're watching this video, you might have to do -preview equals DIP 1000. And of course, maybe some of these things will be subject to change in the future, but this is where this feature exists. So anyways, created a reference type here because that's what the escape analysis runs on. And again, our code has to be marked at safe here. And again, this is where we're escaping here. If I assign this global variable to var, again, something that's local or just scoped within this range here, then I'm effectively escaping and increasing my scope to global. Okay, so that was the idea of what we looked at last time. Now, if I'm just using value types like integers here, this doesn't really apply, okay? Because I'm just making copies anyways. When I pass by copy, I return a copy somewhere else. So, there's no way to extend that lifetime in that sense here, okay? So again, you could try, well, actually, let's go ahead and create our global 2 here. Assign it to var, and let's see here. Yeah, we don't get anything here for the value types. Doesn't matter. Why? Because we haven't really extended the lifetime of anything. We've just put a new value into global 2 here. Okay, so again, that's the idea of what's going on. It's doing that sort of member-wise copy, or in this case, it's just a integer, so it's just copying that integer there. Okay. Actually, I'll leave that. Let's leave that in there just so we can see. All right, and then as far as our little setup here, I created our global, set it to a value, our reference type, and then pass this into our function here. Okay, so it's passing by reference. And if we write out these values, R should be, well, this isn't going to let us change anything here. Or rather, our global shouldn't be mutated in any way, the value that's stored inside of this class. Okay, so that was a recap of last time. Let's go ahead and see how we can improve things here. So again, if I run this, the error that I'm getting, scope variable var at line 10, here is the escape here. So let's go ahead and play around with this again, and let's go ahead and, well, let's see if I just return var here, okay? And you can see I have this comment again if you watched the last video. You notice that, again, scope parameter var may not be returned here, right? Because I'm escaping. And effectively, this thing that's only supposed to have a lifetime of this scope, because that's what we said here between these parentheses, is extending its lifetime. Okay, so if we know what we're doing here, we could do something like return scope here, okay? And if I compile that, that's actually fine here, okay? Because this is telling us, yeah, we're pretty confident that wherever this thing that we're returning is, we can do something with it, okay? Now here's where we have to be a little bit careful and maybe debug this a little bit. Let's actually create a ref type here. I'm gonna call this R2, and we'll just create another one of these objects here. And, well, what I'm returning from this function is this reference type here, so just some sort of class here. And let's go ahead and assign it here. And what I want to go ahead and show you or look at is, well, let's see what the values are and the addresses. Okay, so let's see R's, R2's value. Let's see the address and the address of R2 here. Okay, and for this, let's go ahead and make this just a little bit larger. And since we're not as concerned with our, we know this code is safe here, let's just flip the order around just a little bit here. Again, in efforts to get everything on the screen for you in as large as font as possible. Okay, there we go. Okay, so let's go ahead and finish this off. Let's go ahead and return the address of R and the address of R2. Okay, and let's go ahead and take a look here. R2.value. Again, just lining everything up just for a moment here. And again, as we're learning these things, this is a helpful way to always debug here a little bit. So let's go ahead and compile that. And well, what do we see here? Okay, now the values themselves are 0. I suppose they're not being, changed in any sort of meaningful way. In fact, let's actually, through this var here, var.value equals 8. I don't know, something like that. So let's see if we get any change. And in fact, we do get a change in both of them here, okay? Now, what's interesting here is to see that when I have R2 here, and I'm assigning it here to this value here, well, I mean, it is its own object here, F8, okay? I mean, we can kind of play around with this a little bit here. Again, just thinking about memory here. Let's go ahead and say if R2 was just equal to something like this. Can we do this? Well, in this case, it's still its own memory here for that variable, because again, these ref types here are going to be allocated, or I should say these are going to be allocated on the stack, but what they point to, the actual ref type, right, is somewhere in the heap here. Okay, so just a little experiment here just to show you that those are in fact different. And that's really all there is as far as, being able to return here this particular value. Now, why would you want to do this in this particular case? Now, I'll need to think a little bit about this particular scope here, but something that came to mind here is sometimes we have at safe code that we might want to write that looks something like this. And let's just go ahead and call it allocate. And what allocate's going to actually do is take in an integer pointer here. And I'm just going to call it empty memory here. Okay, so some, integer pointer. And I want to be able to return my empty memory here, okay, that I have allocated. Okay, so let's play around with this. First and foremost, let's see if this is going to compile here. And let's make sure we save here. Compile it. Compiles just fine. Okay. Now, if I do scope here, this should run our escape analysis here and give us an error. Okay, so we're okay there. And if I run return scope, then this is back to being okay. Okay, but this is in fact showing us our intent that, yeah, we're gonna pass something in, and then we're gonna actually return this empty memory here, whatever it points to. Okay, now let's actually try to do the allocation here. So I'm gonna import from the standard C library, the standard lib, so that I can do something like malloc here. So let's go ahead and say empty memory equals, and I've got to cast this here to do malloc and, 4 integers or something of this nature. Now, again, think about what @safe does here. This is for memory safety here. I'm going to compile this and we're going to get a whole bunch of errors here, okay? Because this is a safe function here. I cannot call into system functions here like malloc, okay? And then it's also forbidding me from doing, this dangerous cast here, okay? So a couple issues here. So how do I actually allocate and indicate that, yeah, whatever I put in this memory, I'm going to get something back? Well, I could write another function here, and let's actually just call it, allocator or something, the thing that's going to actually give us the memory. And let's go ahead and copy this code in here. And what I'll actually do here in my allocate function is now I'll do this assignment here. Empty memory equals, and let's think about this a little bit. Well, it should return our allocator. Okay. And the job of our allocator here is just to, allocate some memory, do malloc. So we're going to actually do this manually here. So again, let's play around with this. Let's see if this compiles here. Now, by default, again, this is a little bit of a reminder of our attributes here. We've got it's at system code by default. So we're still going to get, this error here. Okay. Then I've got from our allocator here. It doesn't know anything about empty memory. It's just going to return, some amount of bytes here, right? 4 for an integer times 4, so 16 bytes effectively. So now I'll run it, and then again, we got to make sure that we don't call in a system code. So we've got at trusted here. Okay, so now we should be able to make this call. I'll go ahead and compile it, and now it runs here. Okay, so, I'm just kind of playing around with the code here, but what we're basically doing, and the point in this case of what I'm trying to show with return scope is, again, if I just make this scope here, again, this is saying, well, I can't return my memory here, that I am, passing in some pointer here, okay? But I do want to, on occasion, be able to have some sort of allocation function that can return an integer and allow something to escape, right? We're literally going to the heap through this trusted function here, which is allocating our memory. Again, maybe this is allocating memory. Maybe it's allocating some other heap object, maybe something fancy like a thread pool. This is the kind of space where I might play around with these things. And again, you can kind of dig through the standard library and see where there is return scope to make things safer. I think that's a good place to find some examples, but this is just something I'm playing around with now. But anyways, so that allows us to have this allocate function that we can pass in a pointer and then return some memory. And the allocation happens in some trusted code. Okay, so I'm getting the benefit with @safe of being able to, perform this escape analysis and make sure I don't, do something wild here, like have some global variable. Let's go ahead and do, again, a int global 3 here. Again, just to show like, hey, what if I did global 3 equals this empty memory thing? Well, that's still a problem, right? Because this is scope here, okay? And we're not returning it. That's the one place we're not allowed to do it, okay? So let's go ahead and just mark that. Not allowed, right? Escape. Okay? So we're not allowed to do that there. Now, what else to do with this sort of allocate function here? That might be interesting. Like, why might you actually write this? And you're saying, well, why wouldn't I just, have a function here that does the malloc? And that's probably perfectly fine. But I am making sure that I'm not, doing anything kind of wonky here, again, with globals or something else that's, affecting the state here. And why would I be passing in a pointer here and doing anything with it. I mean, that's kind of an interesting pattern here, but again, maybe you have some sort of object here that has some memory in it, and I'll even give it a better name. Let's call it reallocate. Now in this case, it's just reallocating 4 bytes. It's not doing anything really interesting, but right, you'd maybe pass in the pointer for where the memory exists, delete it or something, and then, you know, call it into your allocator. Okay. And then you'd want to return back the pointer here. Okay. So this is kind of maybe a C style thing here, right? You know, some memory. Okay. I'll just create it here, and then maybe I'll call into it and want to reallocate it, you know, from itself here. Okay, so that's how you'd actually use it. Again, you know, this is just an example to cook up in a teach return scope and maybe show why it's useful, because I want the advantage of being able to run that escape analysis and make sure, again, nothing wonky happens in my @safe code. But just because it's @safe code, you can still do all the things that you want in the language, all the low-level things like allocate memory and call into things and so on. All right, so anyways, I hope that's clear on at least return scope. I kind of cooked up an example here just on the fly of maybe where I might use it or start thinking about using it. And that sort of leads to a discussion of, you know, all these cool features that you're learning, of course, that you're following along here in the course if you want. But, you know, why should I use return scope? Is it making the language complicated? Well, maybe, but, you know, here's my thoughts on that with the D improvement proposal. That's what DIP stands for, and 1000 is the number associated with it. Well, the idea is that with any of these language features, you can choose not to use them, and that's totally fine in this case. So I think there can be tooling and so on to support if you don't want to see this feature. There's various D tooling that's getting set up these days with different parsers and so on, which allow you to, for instance, parse your code and maybe pick out some of these things here. So at some point, you know, looking at dscanner and maybe some of these things, maybe there will be rules where you could automatically say, well, I just don't want to mess with return scope. I think in general, it's good to have some of these language features, and over time, maybe we can decide if you want to deprecate them or not allow them in your actual code. But for the folks who do need this in that granularity of control, you can choose to use this feature. I think overall D is a really clean language and overall very simple if you want to use the simple parts of it. And again, you know, we have to kind of cook up some cases with this return scope, and through practice, again, you know, you'll be able to make some of these design decisions. And again, oftentimes I think some of these high level of control of these features are very useful for folks building libraries and trying to build safe code here, which I am a fan of writing safe code. And again, a reason I like this language. So anyways, folks, just a few thoughts there. Hope you found the discussion interesting. I'd be curious to hear your thoughts. And again, I'm categorizing this particular lesson as sort of advanced in the sense that this is something that maybe, you know, some large % of you will never need to use if you're just trying to build cool stuff with a D programming language, which I, as always, encourage you to do. Anyways, folks, thanks for your time and attention. Hope you enjoyed this lesson, and we'll get back to your regular programming very, very soon. I'll see you there.